Okay, so today we're going to continue looking at the example that we started in the previous class. That was example about banking. On Scholar, I have posted in the folder, I believe it's in the folder Data Files, okay, the script that we kind of sort of started in the previous class. Bank classification tree.r. So if you don't have the script in front of you from the previous session on Monday, and you can go ahead and download that. And which browser are we not using ever again? Internet Explorer, okay? So in a non-Internet Explorer browser, you can download the script, double click on that, and it will open in RStudio, and it will look like this. And I believe I need to magnify the screen. So there it goes. Whoa, that's a lot. Okay, so that's where we finished our previous class, right? So let's go ahead and run these two lines. Okay, so I'm going to select all of that and run it. So the data that we have, reminder, deals with bank customers. There are 5,000 bank customers in the data set, and we know 12 things about them. There are 12 variables. The one that we're targeting, that we want to predict, is called personal_loan. Okay, so the idea basically is bank gets in touch with customers and tries to convince them to take out a loan, unsolicited loan, right? So that means that customers didn't express their desire to get a loan, bank just said, do you want to get a loan from us? Okay, so, and we know about each customers where they did get a loan, in which case we have a yes or a 1, or they didn't get a loan, in which case we have a no or a 0, right? And what are we using as predictors? Well, the rest of the variables. Customers' age, number of years experience, their income in thousands of dollars, how many people in the family, average credit card monthly balance, level of education, that's categorical variable, BS, doctorate, or MS, right? What else do we know? Their mortgage balance, if they have that with a bank, 0 if they don't, right? Securities account, do they have it with a bank, yes or no? CD account, do they have it, yes or no? Do they do online banking? And do they have credit card issued by this bank, right? So some of the predictors are categorical, yes, no. Level of education is categorical. The rest of them are numerical. So it's a mixture of both types, right? Categorical and numerical predictors. Okay. Now, important thing that we finished discussing in the previous class is this, right? Overfitting. So let me remind you, because this is a very important concept in data analytics. Our goal, whatever we do, right? We want to build a model that predicts the reality as accurately as possible. So, specific to this example, some customers say yes, most customers will probably say no to a loan from the bank, right? So we want to be able to build a model such that if we run the model, we'll capture things correctly, right? For people who did say yes, we predict accurately they did say yes, and for those that declined it, we predict accurately that they said no. So from that standpoint, we want to build as detailed tree as possible. But the caveat is that people are irrational creatures, right? So sometimes they do things not because of rational explanation, but because they feel like doing it, okay? And that includes getting, for example, loans, right, from the bank. So therefore, our data set contains both the main features of the model, right? Who gets a loan? Well, people with high income or low income, people with high family or low family, some things that you can explain and anticipate, right? Plus some noise, which means that this person should not be getting a loan, but they did, okay? And that's just randomness in the decision making, right? This is noise. That's something that we don't want to capture, right? Because noise from one data sample to another data sample will be different. It's not going to be the same, right? But what will happen if we build very deep, very deeply split tree with a lot of branches and a lot of decision leaves? we're going to start at some point capturing noise, right? And that's what I try to illustrate with this picture right here, okay? So we're splitting the data set into two subsets, right? One of them we call training, and we use that to build our model. And we agreed that never we're going to use the word build again. We're going to use the word train. We're going to train the model, right? Typically, training data set is much larger, okay? Several times larger. Obviously, if you get more splits into the tree, so here I have, number of splits going up, right? And you can see that the error rate, misclassification rate, is going down on my training set. The bigger model I build, the more accurately it tells me, it predicts for me who will get a loan and who will not get a loan, right? The less errors I'm making. But at the same time, if I take this model and apply it to the validation set, the rest of my data set, right? Initially, the error rate will go down, but at some point it will minimize, right? It will hit the minimum point, and after that it will start going up. Why? Because I'm starting overfit my data. What does that mean? My model follows the data very closely so that it captures both the main signal that I want to model plus the noise, these random decisions that cannot be explained by anything in the model. It's pretty much irrational in a lot of cases, okay? But the model captures them anyway, right? You can split it deeply enough so that you can start approximating your data very, very closely. But some of that will be noise that you want to leave out, okay? And when you apply this model to a different data that the model have not seen before, that is our validation set, the error rate will go up because noise in the validation set is different from the noise in the training set. So therefore, errors actually keep climbing, okay? So basically what I'm saying is this. You should not build a tree anywhere above this threshold where your error or misclassification rate on the validation set takes the minimum, right? Because after that, you're starting to build a model that captures the noise in the training set. And you can see that by difference, right? So if I build a model, for example, this big, right? The error on the training set will be low, but the error on the validation set will be high. And that's how you know that you're overfitting the data. If you calculate the errors on the training data and on the validation data, if there is a big difference between these two misclassification rates, that means that you have overfitting, right? You're following the training set way too closely. Your validation set doesn't like that because it has a different noise, and that's why your errors are higher, getting higher, okay? All right, so this is a little bit of the background. Okay, let's do slicing and dicing of our data finally, right? Okay, first things first. Let's see how big of the response rate are we talking about, okay? So how many people in my data set? 5,000, right? Let me see how many people actually responded to the advertising or to the offer yes or no positively, okay? So this is something that we did a couple of weeks ago. This is just a reminder, right? So I'm going to create, okay, hold on, yeah, lowercase, yes, no count. I'm going to count, ask R for me to count how many people out of 5,000 agreed, said yes, and disagreed, said no. Remember how we did that? How did we count different categories in the categorical data? We used the function table. So let's do the table, okay? Let's create tabular summary of the variable. Which variable I'm talking about? Out of these 12 variables. Personal loan, right? Who said yes, who said no, that's included in the variable personal loan. Do you remember how I'm referring to the variable inside my data? The $sign, right? I need to type the data set name, which is bank underscore data, $sign, and pick the variable which I'm looking at, okay? So let's run, yeah, I didn't run it yet, okay. Let's run this line, there you go, okay. And now let's show what's the count, yes, no, count. Okay, so there it is. So it says that out of 5,000 customers of the bank that were sent the invitation to apply for a loan, 4,520, there was no word from them, which means didn't happen, right? And 480 said yes, well, in some form, right? They contacted the bank, applied, got approved, what have you, right? So there was some communication with them. Okay, so I don't want counts as much as percentages, right? I want to see in what percentage of cases I was successful. Remember how we did percentages or proportions? Uh-huh. Say again? No, go ahead. Ah, yeah. Okay, yeah, you have to spell it precisely how it is, and our lowercase versus uppercase. Okay, so I'm going to do the prop table. If you remember, we did that before, right? When we looked at Titanic example. So prop dot table, and prop table needs to get a vector of counts, right? So the counts that I created, that's really a vector, yes, no. So I'm going to send yes, no count, and if I run this line, prop table of the count, okay, if I run this line, there. What do I see? 90.4% of all people didn't do anything about it, right? So they basically threw it in the trash. And 9.6% of the people, they did contact the bank and said, yeah, I want to apply for the loan, right? So roughly speaking, we're talking 10% response rate, which is probably reasonable, maybe even a little high. In actuality, banks probably can expect only what, like 2%, 3% response rate, right? That's realistic, okay? So 10% is a little bit on the high side, quite honestly. Okay, now let's do some preliminary kind of investigation, okay? Somewhat. For example, level of education, okay? Does the level of education affect people's desire or willingness to apply for a loan, okay? So here's how I can do it. True or false? My variable personal loan is categorical. True. True or false? The variable education, I believe that's how it's called, right? Where is that? Education, yeah, is also categorical. Yeah, PS, doctorate, MS. What do we call a tool where I can see simultaneous distribution of two categorical variables? Cross tab, right? Let's create a cross tab between education and the personal loan and see what happens. Now, to create a cross tab, what do I need? Can I just start typing cross tab? Which library? No. Gmodels, right? R part is for partitioning, okay? When I create the tree model. I need to look at I need to load the Gmodel, so therefore I'm going to say library, Gmodels, if it's installed. I hope it's installed. If not, then you have to install it first, right? Okay, so I'm loading the library, and after that I'm going to create, here I'm going to say create cross tab between education variable and personal loan. Okay, so let's see. As I start typing cross, I see the function that I need, right? That means that the library loaded just fine. Cross table and two variables, right? But how do I reference these variables? First, I need to type bank underscore data, the data name, right? Bank underscore data. And then $, and I'm going to pick education, right? That's my variable number 1, education. And the variable number 2, I'll do the same thing, really, right? The name of my data, which is bank data, $, personal loan. So I'm crossing education and personal loan. So let's go ahead and run this line. I hope it works. Yes, it does. Good. Done. Okay, so there it is. All right, what do I see? Well, I see that out of these 5,000 customers right here, okay, 2,096 were bachelors, right? 1,501 were doctors, and 1,403 were masters. Okay. Now, I want to compare percentages in each group, right? So as if each group is separate from everything else. So education is horizontal in the records, in the rows, right? So therefore, I'm looking for percentages out of row totals, right? That will give me the percentage breakdown of no's versus yeses among bachelors of sciences, and then after that, doctors, right? So let's take a look. Here's my legend, how to read this chart, right? You see n out of row total. It's the third one, right, in the middle. Okay, so I see that in the bachelors of science, the third one, what's the meaning of this 0.956? Tell me. 0.956 what? Exactly. That's the percentage of people among bachelors, right? Among just BS education, okay? No pun intended. Who declined the offer, okay? So 95.6% bachelors of sciences declined the offer, and right here it's everybody who accepted, the proportion, right? 4.4% accepted, okay? That's only out of this group. Only out of Bachelor of Science, because it's a row percentage, right? Okay. What can we see about the doctors? Doctors, among them, 86.3% declined, right? And 13.7% accepted, correct? That's how I interpret that. Masters of Sciences, let's see, 87% declined and 13% accepted, right? Out of these 1,403 people, okay? So by looking at three numbers, so I'm looking at yeses, right? That's what the banks are interested in, right? What percentage of people said yes? Because if you said no, this is where the story ends. But if you said yes, that's primarily the target interest group, right? So 4.4% in BS, 13.7 in doctors, right? And 13 in MS. So what do you think? Level of education, does that affect the people, let me use fancy word, propensity to accept the unsolicited loan offer from the bank? It does, right? How can we tell that? Well, 13%, 13.7% are high, right? And 4.4% is, roughly speaking, 3 times lower, right? So the percentage among BS degree holders is roughly 1/3 of the percentage for doctorate and for masters, right? So therefore BS degree is 3 times less likely to accept the offer of the loan from the bank, right? Well, that's significant, right? So therefore level of education does apparently affect how likely people to answer yes to a loan offer, and therefore I expect that to be an important variable when I build my my sheet, right? Probably it's going to be an important variable. Okay, so let's just for the kicks, let's do another one. Let's do, for example, online banking. If people do online banking versus don't do online banking, is that going to be important? What do you think, even without looking? Like I do online banking and Ali doesn't, for example. Okay, so if the bank sends us the postcard that says, "Hey, go ahead and apply for the loan," are we equally likely to apply or equally likely to not apply? Who knows? Let's see. Okay, I'm going to do the same thing exactly. Okay, so let me just copy paste this portion. Okay, create a cross tab between now what and what. Instead of education, I'm going to use what's the exact name? Online banking. Okay, online banking. And here in my cross tab, right, instead of bank data $education, I'm going to say bank data online banking. Where is it? It's right here, okay? And I'm going to run this line. Well, let's see if there is a big difference between percentages who accepted the loan offer. So here is my, where is it? Yeah, no, that's education. Hold on, did I not run the line? Okay, let's do that. Yeah, no, still not here. Why? Why do I not see this thing? Yeah, there you go. Okay, so, well, ladies and gentlemen, tell me. I'm not going to say anything, you tell me. Among people who don't do online banking, what percentage agreed to a loan? 39? 9.4, right? Again, I'm looking out of the row total, right? Just the people who said no, okay? Out of row total, that's the third one. 9.4 agreed to a loan, right? Among people who do the online banking, which percentage said yes? 9.8. Is there a big difference? Not really, right? Almost the same. So I expect online banking to be not really an important factor, right? When it comes to the tree, probably I will not see a split. And what do I mean by important variable? Does it participate in the tree? Is it one of the variables that splits the tree? Or is it completely ignored by the tree, right? If it's completely ignored, that means it's not important, right? Splitting on this variable will not result in bigger accuracy at the end of the day. That's what it is. And if the variable becomes part of at least one split, that means, yes, it is important, right? It does improve the accuracy of the model. Okay, make sense? Yes, ma'am. Oh, that's because, you see that? 1, 2, 3, 4, 5. 5 numbers, right? And here is the legend. Every time when you run it, it tells you what are these 5 numbers. First is just a count. So, for example, that one says that 189 people don't do the online banking and they agreed to the loan, right? Yeah. We agreed to skip the second one because it deals with chi-square test of independence, which we're not doing in this course. We've done it earlier in VUS Center 31 statistical thinking. Okay, so third one is count out of row total. Fourth one is count out of column total, and the last one is count out of table total. Right. So therefore, during the exam, pay attention to, what are you looking for really? Okay, is it out of row total, column total, or grand total? Okay, pick the appropriate one. All right, make sense? All right, ladies and gentlemen, let's do this. Now I want to split my data set into 2 sets. How do we call them? 2 different sets. Training and validation. Which one do I use to build my model? Training set, right? And I told you in the previous class that training set is usually bigger, right? So let's do this. Let's split it 80% training, 20% validation, okay? So, there it goes. This is going to be a little weird, but this is how things are, okay? First things first. Let's split our data set so that my split is the same as yours, okay? So for that, we have to use something that's called seed value. I'll try to explain the meaning of seed value as best as I can. So here, let's go ahead and say set.seed, and let's use the same number, that's important, 100. Why 100? Because it's a cute number. I like 100, okay? No other reason really, right? What does that do? So when we run this line, nothing really happens visually, okay? But it generates a random value, and because we use the same seed, 100, everybody in this room generated the same random value, okay? And this random value later we're going to ask R to use that to split things randomly, okay? So here's what next I'm going to do. I will generate, what's 80% of 5,000 records? Tell me. 4,000, right? So in my training set, I'm going to have 4,000 records. How many records in the validation set? 1, right? So here's what I'm going to do. I'm going to say random sample, random underscore sample. That's the name of my variable, okay? And inside this variable, I'm going to say, do the sample for me, please. And now I have to say how many numbers in total, 5,000. And how many numbers do I want? 4,000, okay? I know it doesn't make much sense now, but in a minute it will. Let's go ahead and run this line, okay? So I created an object or something, some weird blob of stuff, right? Which is called random underscore sample. Let's see what's inside. How do we see what's inside the thing? You just type it and say, hey, show me, okay? Random sample. Bam. All right, so my first random number is 1539. Do you have the same? You should have the same, right? Second is 1289. Next one is 2761, etc., etc. So we ended up with the same breakdown because we used the random seed value. So when we said set seed 100, I did that, you did that, we ended up with the same random seed value, okay? After that, this seed value was used to create a sample, right? What's the meaning of this? Okay, the meaning of that is, here I asked R to create 4,000, to pick 4,000 numbers randomly out of 5,000 numbers. That's what it is, okay? So it said, the very first record that you're going to need is record number 1539. Out of 5,000 records. The second one is record number 1289. Okay, so essentially, what I created this function, this variable random sample. Now it contains indices of the records which are going to be picked to be what? Training set, right? I asked the R to pick randomly 4,000 numbers out of 5,000, okay? So what I'm looking at are literally indices of the records which are going to be used as training set. Simple as that. 4,000 records. So now let's go ahead and get the training set, okay? So now I'm going to make a comment and say create training set. And you know what? Because I'm very unimaginative person, I'm going to call it training set. Simple as that. Training, but I don't want to have space. What do I do? Underscore. There you go. See? Getting into the spirit of Christmas. At least programming Christmas. Okay? Training set. Training set is going to come from the bank data, right? That's it. And here's what I'm going to do. Weird thing number 2 for the day, okay? I'm going to say square brackets, okay? And in the square brackets, the first thing that I'm going to type is my random sample. And after that, I'm going to say comma and type nothing. And leave it empty or put space, doesn't matter, okay? Here's what it's going to do. It's going to pick up only records which were selected for the random sample. Okay, that's what the first line is. Okay, this first portion. All right. Second portion I'm leaving blank, which means select all columns for that record. Okay. So first record is going to be 1539. All columns: personal loan, income, credit card balance, education, family size, blah blah blah. All of them. Okay. So because I'm leaving that empty, it will pick all columns. That's the meaning of it. Okay. So I'm going to run it, and hopefully you will see no red. That means no errors. Okay. Now, true or false? My validation set is whatever is left over. Yeah. So what I didn't pick for my training set becomes my validation set, right? Here's weird thing number 3. How do I do that? Well, let's go ahead and do the comment create validation set. validation set. Okay. And here is how I tell R to do that. Well, can you guess how I want to call this validation set part? Validation underscore set. Okay, validation underscore set. Set. And I'm going to say same thing, bank data, square brackets, okay? But now I'm going to say take everything except that. So essentially remove my random sample, and whatever is left is going to be your validation set. So remove, I'm going to signify by just saying minus. Remove the random sample, in the rows with indices that correspond to the random sample, and again, whoopsie, take all the columns, right? So comma, nothing. So that means that all columns, okay? So for training set, I say from the bank data select the random sample. For the validation set, I say remove the random sample, and whatever is left, that's going to be my validation set. Does it make sense? All right. So let's go ahead and run the second line. So how many records should be in my validation set? 1,000. Let's check if this is true, right? Let's look literally into the training set and the validation set. So I'm going to start typing training set and run it. Okay. There should be a summary. Oh, it's not. Oh, okay. So I don't want to look at the records. Sorry. Let's look at the structure, okay? I don't want to see the records. I want to see the structure, okay? str, right? str of my training set. Just like what I did with my data initially, okay? Bam. Do you see that it does contain 4,000 records? It says so literally, right? 4,000 observations right here, okay? So that means that I did the split correctly, right? Well, and just for kicks, let's also copy paste, right? Good programmer should be lazy. Okay, that's what I keep telling my daughter. She's like, yeah, it's easy for me to type the whole thing. I'm like, no, it's not. Copy paste it and change the parts that you want to change, okay? So I'm going to copy paste this thing, and instead of training set, I'm going to see validation set. Okay. And it says that validation set has 1,000 records, right? So apparently, I did everything correctly, okay? Any questions, ladies and gents? How are we doing? Yay? Hey? Hungry. Oh. Oh my God. Did you use the setseed 100? Okay, let's take a look at that after the class, all right? Because hey, it shouldn't matter. I mean, R is R. Now, let me ask you this question. Are your computers PCs or Apples? PC. So, should be identical. All right, well, that's bad news. So, let's take a look at this, okay? After the class. But, here's what I'm going to do. Now it's time to do the tree, right? So, which set do I use to build my tree? Tell me. Training set, right? Yeah. And which library do I need to use? rpart, okay? So let's go ahead and load the rpart, right? Library, rpart. So now we're getting ready to build the tree. So run the library line. And after that, remember, we did that a couple of times, right? So I'm going to give my model sophisticated long name. How about I call it bank underscore classification underscore tree underscore model. Very descriptive. Okay? Alright. So I'm saying use the function rpart, right? So, well, now I'm going to shut up and you tell me what's the very first thing that we have to tell our function? Bank data. Okay, so let's do data equals Is it bank data? It's a training set, right? Why did we do this whole shebang? So that we have training set and validation set, and training set is used to train the model. That's what we're doing, right? So training set, it's right here, okay. But even before I do the data, what should I tell the model? Not the model, the function, our part. What is my target and what are my predictors, right? What is my target? Yeah, what's it called? Personal loan, right? The column called personal loan, all lowercase with underscore in the middle, right? That's really yes, no, that's what I'm trying to predict, right? That's my target. So I'm going to say personal underscore loan is my target. What do I do next after that? I do this, tilde, right? That means this is my target, and what is about to follow are predictors. And how do I pick all of them? Period, right? Comma. So this is me specifying what is dependent variable, target, and what are independent variable predictors, right? And I have the data, and the last thing, remember our discussion at CART, classification and regression tree can do both of them. Classification and regression. This one is what? Classification. Why? Okay. Because the target is categorical variable, right? Personal loan is yes, no variable. It's a categorical variable, so therefore method, well, not method, but method that I have to use is quote unquote class, right? This is the right way to set up your R-part function. And that's probably something that you want to put on your cheat sheet for Friday, right? So that if you forget how to do these three things, you can quickly consult with your reference, okay? So let's go ahead and run it. Apparently it's there. Okay, well, let's look at it, for crying out loud, right? Let's look at it. How do I look at the tree? I type it like this, copy paste. Remember, good programmers should be lazy. R-part, yeah. I mean, we can do it. Don't repeat what I'm about to do, okay? Because it's going to be awful. Bam. This is the tree. It's not as sexy. It's kind of flat a little bit, right? But it tells you exactly the same information as the tree that we're about to see, okay? So the reason why we're using R-part plot function is to avoid that, okay? Have the tree in a good looking format, okay? So therefore I'm not going to do that. Instead of that I have to load another library, right? Library R-part dot plot, because that's the library that plots the tree. Bam. Okay. And after that I'm going to say R-part dot plot. Please show me my, and now this really long name for my model, right, for the tree. Bank classification tree model. Bam. Okay. Essentially I'm saying, show me the tree, please. I want to see visually what is going on. Okay. And this is my tree, right there. You should get the same, pretty much, picture, right? Okay, cool. Now let's take a look at the... Okay. So after I build the model, I load the rpart.plot library, and I say, show me the tree. Bam. Okay. All right. Well, let's see. True or false? The variables that are participating in the splits are important. The variables that are not part of the splits, they're not important. Sure? Remember, we looked at only two of them, right? We looked at the education and online banking. Is online banking part of the split, of any split? Not really. So our initial hunch that it's not going to be important actually is validated. And education, what did we say? Bachelors are 3 times less likely to get a loan than others, right? Is education part of the split? Yeah. So there you go. Okay. All right. So let's quickly summarize who are the people that are like target group, right, for this bank. Am I looking at the first of all, where do I look in the tree? In which of these nodes? Which part of the tree am I supposed to analyze to answer the question, what type of people? Terminal leaves, right? I don't really care about all of this because that's not the end of the journey, right? If the leaf keeps splitting, that means that, yeah, you have to split as far as you can until there are either no more splits that result in an improvement, right? Or we just simply run out of variable, right? So here probably there are no more splits that will result in a better tree, okay? All right, so I'm looking at the terminal leaves. And do I look at leaves that are classified as no's or yeses? Which ones, yeses or no's? Yeses, okay? Because the bank is interested to see who will accept the loan, right? If people didn't accept, well, this is where the story ends. You can send them more materials, they will throw in the garbage, right? Nothing will happen, okay? Now, is that always the case, that we're interested in yes and not a no? Not necessarily, okay? For example, let's say employees in an organization, okay? Let's say I want to predict who will leave the company, okay? And I have the variable called, did they leave, yes or no? Other way around, did they stay, yes or no, okay? So if they stayed, it's a yes. But that's what I expect, right? What I want to predict is people who will leave. So zeros or no's, right? That would be my target interest group. So therefore, please be careful about the context, okay? Are you interested in yeses or in no's? Because it all depends on the context of the problem, right? In this case, we want to see who will accept the loan, who will say yes. In other cases, you may be interested in zeros who said no, right? That would be your interest group. Okay, so I'm interested to see what about the yeses. And there are four of them, right? So let's kind of see what kind of information can we get. So let's start with this one on the far right. You tell me, what are the characteristics of this group? What kind of people end up in this leaf on the far right? Uh-huh. Uh-huh. Exactly, right? Remember how split is done? Yes goes to the left, no goes to the right. So first decision, income less than 114. No. That means greater than 114, right? We get more than $114,000 a year. Then we go here, education bachelor. Yes goes to the left, no goes to the right. So this one is to the right. So therefore this leaf contains all people with high income, more than 114,000 bucks, and education is either docs or masters, right? That's your first target group, okay? Now tell me about this target group right here. Next one. Income is what? Greater than 114, right? Is it less than 114? No. So it's greater than 114. Education? Bachelor's, right? Because we went to the right. And that's BS. Yes to the education equals BS, right? Okay, and the last one, family size greater than 3, right? So people who get high income, who have bachelor's degree, but they have big family. And that's probably the reason why they get the loan in the first place, right? They have more than 3 people, 4 or more people, right? His husband and wife, 2 kids, maybe more, right? So these are the people who will likely say yes, and look at that. 100% of them said yes. Do you see that? Do you remember what's the meaning of this fraction? It's the percentage of people classified as yes, right? In that leaf. So the first one had 96% yes, and this one has 100% yes. So this one is pretty big one. So how about this one? Tell me quickly. What is the typical profile of this leaf? Income is under 114, huh? Yep. They have average credit card balance monthly greater than $3,000. This one is tricky, right? CD account, they don't have a CD account. Yes goes to the left, no goes to the right. So if they do not have CD account, it goes to the left. CD account no, yes. So therefore we go to the left. So which one goes to the right? CD equals no. No, that means yes, right? It's kind of double negative, right? They are not and no CD account people, right? Which means that really they have a CD account. Okay, so low income, less than 114, high average credit card balance, over $3,000, and they do have a CD account with the bank, right? And let's do this last one. Same thing, right? Income is less than 114. High average credit card balance, right? What else? Do they have CD account? No, right? Because CD account equals yes, goes to the right. So they don't have a CD account. Their income is what? Next one, it splits on the income again, right? It splits on the income one more time. Greater than 93, right? Because less than 93 goes to the left, higher than 93 goes to the right. So income is greater than 93, but less than 114, right? So this is like a narrow band of incomes, right? And education, what's their education right here? Masters are dogs, right? Because education BS goes on the left, no goes on the right. That means PhDs or masters, right? So that's your fourth profile. Okay? All right. So does it make sense? Will you be able to do something like that on the upcoming exam? We'll see about that, right? Okay. So this is it for today.